Right, I'd like to welcome everyone to Denbigh Radio Club for the latest of our weekly club meetings. As you know, and lots of familiar faces in the room here tonight, our meetings are not just open to paid up club members of Denbigh, but anyone who's interested in amateur radio is welcome to attend our club talks. That's a principle we started a year ago and a principle we've agreed we're going to carry on doing. It's proved extremely successful, and it has resulted in lots of new people joining the club because they've enjoyed our meetings so much. So welcome tonight to tonight's talk. We've got John, G8SEQ, who came up with a fantastic title, John, Sustainable RF. I'm going to let John explain this. But two things I wanted to mention about John. I met John briefly when we were organising last year the GQRP Club National Convention, or International Convention as it was, over a couple of days, and John was one of those who took part in that event. But I noticed on John's little biography on QRZ.com, and I want to mention this to all those, which is obviously the bulk of people in the room here tonight from Yorkshire, that John started his work in life in the mining industry as a technician in the mining industry. And of course, you know, where we are in South and West Yorkshire, there were vast coalfields across Yorkshire employing literally hundreds of thousands of people, you know, up to 40 years ago in this country. So we've got long links with the mining industry, and I know Denbigh Club has run a special event station at the National Mining Museum here in Yorkshire for several years, a few years ago, so we have got good links, John. So I'm going to hand over to you, John, you're able to, if you want to run a presentation, you're able to do that whenever you want.
Okay, thank you very much, Nick. Just one point of information on mining. Coventry had the second deepest mine in the country after Betsanger in Kent. Little known fact. Anyway, I'll share screen. No, it won't start again. Well, this came about due to our local club, Championship Radio Society, wanting to operate Field Day. That's VHF National Field Day. And this dates back to the 2002 contest. That's interesting. This slide says, and John Beach G8SEQ. There should be another name in there, which is Bob. Right, the Sustainable Station. There we are. My friend Bob Nash, G4GE, did a lot of the work putting this talk together, actually. So the aim of this particular National Field Day was to avoid the use of petrol generators. We never actually used petrol generators anyway, except once, I think. Most of the time they were diesel because you don't get any ignition interference from diesel generators. But we were going to operate 4 stations using renewable energy. And we used omnidirectional aerials to avoid the use of power consuming rotators. There were other reasons for using omnis as well, which I'll talk about later. And they have other benefits apart from not having to have a rotator. So what is VHF Nfd? Well, the original idea was to assemble and operate a portable setup for emergency communications. But in the rules, it says you're allowed 24 hours to set up the station, and you operate it for 24 hours if you want to. We never bothered operating right through the night. So we tended to operate for about 16 hours out of the 24. Right. In reality, it's a contest situation to work as many stations as possible on 4 VHF bands. It was actually increased to more than that. And there are different sections which you can enter. And as I said, it was up to 24 hours operation. So what are the sections? You've got various sections for single and multiple operators. And we entered ourselves in the restricted section. Now, the main restriction for the restricted section is actually single antenna and a maximum height, which I can't remember off the top of my head, but it was something like, I think it was 10 meters was the maximum height. And you were only allowed one aerial per band for the restricted section. Height restriction was 40 feet in those days. And the maximum power you could run was according to license, but we didn't actually have the equipment to run full power anyway, so we never did. So where did we operate from? Well, that is the view looking towards the Urals, and that hill almost in the middle of the picture is the highest piece of ground between where we were and the Urals. So we had a pretty good takeoff to the east, and we had a clear takeoff in every other direction. Apart from, there was one part of the country park, which is actually higher than where we ended up. At one time, we used to go on top of the highest point, but the access was difficult for vehicles. And eventually the park authorities stopped you going up there with vehicles anyway. So that's its actual location in latitude and longitude. Burton Dasset Country Park is in South Warwickshire, about 20 miles as the crow flies from Coventry. So it used to take us about an hour to drive there, bit less. And it's not the highest part of Warwickshire, but I think it's the second highest after Edge Hill. Anyway, it's 688 feet above sea level. Right, the bands chosen were 50 megs, 70 megs, 144 megahertz and 432 megahertz. Strictly speaking, there are only 3 VHF bands there, but the UHF band has always been part of VHF NFD as long as I can remember. And also 1296 megahertz is included. And at one time, they even had 10 gigahertz in the VHF NFD, but I think that had been dropped. The 1296 megahertz was a sort of a station that I put on and operated from time to time when there was nothing much else going on. I'll talk more about the Omni Fly Swatter later. Right, the rigs we used for 6 meters, we had a Yaesu FT847, which would deliver 100 watts, and we operated that for 8 hours. 70 megahertz, we used the same rig before it was modified, and it used to draw something like 24 amps at a nominal 12 volts, but only gave 8 watts of RF out. Most of it was being wasted in the output filter, which has since been modified, and you can get a respectable power out of it now. I think it does about 40 watts. There are various mods you can do to it to improve the power output. And on this year, we used Kenwood TR 751E at 25 watts, and 432 we used the FT 780. The 1296 megahertz station was an IC 736, which only put out about 10 watts. Right, the aerials we used, or antennas if you prefer. These were all double turnstiles except for 77s, which was a quad turnstile, which was 2 double turnstiles stacked one above the other. I don't think, strictly speaking, the 432 antenna at any rate was strictly allowed in the restricted section, but the RSGB never took us up on it, and we got away with it anyway. One of the restrictions is you're not allowed any stacked or bayed antennas, but my claim is they were single antennas because they were all phased together. Anyway, and that's what a double turnstile looks like. Admit Steve Wilkins. Right, I've tried sort of various different phasing harnesses on it, and this is the one I finally came up with, which was easier to construct and seemed to work as well as anything. Basically, there are 4 dipoles, and if we look at AC and AC dash, those are in phase, and DB and D dash B dash are in phase, and they're separated by 1 wavelength in coax, taking the velocity factor into consideration. But this loop here makes this leg longer by a 1/4 wave than the other, which produces a phase shift. The net result of that is the radiation pattern looks like this. That's a slice through it vertically. So the main lobe is this one here. This one is showing a gain of around about 6 dB. This is for a single turnstile. It's a generic pattern. The double turnstile actually has got more gain than that. It's got nearly 9 dB again in these lobes. And the angle of radiation you'll see is pointing slightly upwards. This angle here depends on how high the antenna is in relation to the ground, because these antennas rely on ground gain. They rely on the reflection and the gain to produce this radiation pattern, which is quite useful. These are the lobes and are elliptically polarized, and the one going straight up is circularly polarized. So they can be used for space communications. They're quite a versatile antenna in a lot of ways. There's a few pros and cons on these antennas though. Is because they're omnidirectional, they'll pick up noise from any direction and you can't null it out. So that's a disadvantage. The advantage is though that when you're transmitting, anyone that's in range will hear you whatever direction they're in. So if you're able to run a substantial amount of power, it's good for keeping your frequency clear, because you don't get people muscling in on your frequency when you're beaming in some other direction. So everybody gets a bit. If you get these antennas too high, this radiation pattern gets very messy and it produces lots more lobes. And as I mentioned before, this is an omnidirectional fly swatter that I used on 23 SEMs. It's a 1.4 meter dish fed with cross dipoles, which gives you circular polarization, and the cone at the top has got a solid angle of 90 degrees. So it's like a 45-degree fly swatter, but going all the way around. Now, people tell me this antenna doesn't work, but I know it does. It was a bit of a pig to put up, because that cone originally was suspended on a gibbet made out of scaffold poles, and the dish was on the roof of my car pointing straight up. The way I've got it mounted, I could actually tilt the dish and point it directly at a station, and I did this for comparative measurements, and I could hardly tell any difference in signal strength with pointing the dish directly and receiving it off the cone, and nobody seemed to notice when I transmitted using the cone reflector or whether I pointed the antenna directly at them. So the reason people say it hasn't got the amount of gain that I think it's got is because the signal's been spread through 360 degrees, but the beam that's coming out of here is the same as the beam width of the dish, which is just a few degrees. But because of the way it's being fed with circular polarization, it's as though this beam that's coming out here is being rotated at 1,296 million times a second. So it's effectively, it's as though you had just a single plate fly swatter that was rotating at that speed. Anyway, oops. All right, the rest of the station. The tent, that's our main operating tent. There were other tents that we used for sleeping accommodation. You can see the turnstiles there. That is the 70 megahertz one. There's a quad turnstile behind for 70 SEMs, and the 6 meter one is over here on the right. And the guy ropes were made of Kevlar, I believe, or possibly they could have been polypropylene, but anyway. And there's a wind turbine, which is that's an action photo. Let's, oops. It only looks as though it's got two blades there. The other one's edge on. Well, it was turning. It's funny that on this one it's blurred, and you can also see a couple of solar panels. So power requirements. The total energy budget was estimated to be 500 amp hours at 12 volt nominal with no reserve. And this was based on standby currents for the receivers, 30% duty cycle for the transmitters, for 50% of the time, plus ancillaries. The ancillaries mainly being laptops for logging. But the total capacity we had was almost double the 500. It was nearly 900 amp hours. And the sources of power we had to recharge the batteries while they were up there was a home-built wind generator, which I made, and 3 commercially available solar panels. Right, the generator. There's a modified Honda motorcycle alternator, and I rewound it so it became a 3-phase 6-pole generator, and it would deliver 225 VA maximum at 15 volts. Very rare that I ever got that amount of power out of it. But its output voltage rose with the increase in RPM, which is a bit of a nuisance. But at 350 RPM, it delivered 13.5 volts, which rose to 25 volts at 650 RPM. And the bearings I used were preloaded taper roller thrust bearings. They were actually wheel bearings for a car. Don't ask me which model, I can't remember. But they had 1-inch holes up the middle, which was convenient. Right, the regulator is a bit of a crude device, really. It was an electronically switched dump load. So if the voltage rose above 14.4 volts, it switched a load on to the generator and the solar panels, for that matter, which was basically a resistive load. It actually consisted of light bulbs, so they were self-indicating that I knew when the load was being switched in. In practice, it very rarely came on. It did come on a few times when there were large gusts of wind. Yeah, the turbine weighed about 10 kilograms, and it would self-start if the wind speed was above 6 miles an hour. There are better designs than the one I use for wind turbines now. This one suffered from an effect known as cogging, because it used a soft iron core for the windings. The permanent magnets tended to stick, and you needed quite a bit of torque to overcome that, which is why it wouldn't start up until 6 miles an hour. But below 6 miles an hour, it wouldn't generate anything much anyway. For maximum output, it needed a constant wind speed of 18 miles an hour, which on this particular weekend very rarely happened. That's a close-up view of it, painted battleship grey to match the sky. Actually, the weather this weekend wasn't too bad. You can see there's some sunshine lit up. Incidentally, it uses the tail fin to weathercock it, so it's pointing into wind. And this yellow tube is actually a piece of 2-inch gas pipe. That's a 2-inch bore, and it fitted over a 2-inch scaffold pole and formed a self-lubricating bearing as the luffing bearing. Inside the scaffold pole, I had some polypropylene rope. It was a loop. One end of the loop was tied to the generator, and the other end was tied to a crossbar, and I'd put some twist in it so that this thing could rotate round and round and twist up the rope, and then the rope would act as a spring and it would unfold. It worked very well. You get some odd gusts sometimes, and the generator will go through more than 360 degrees, but it would always come back and point into wind. but the twisted rope would limit the amount of times it would turn, so it didn't twist the cable up, because the cable was hard wired. There's no slip rings in this generator. It was an AC generator, and it went into a 3-phase bridge rectifier. Right, the solar panels. Panel 1 was a 10-watt panel made by Unisolar in the USA. It was made up from 8 individual flexible panels of crystalline silicon wired in series to give 20 volts open circuit in full sun, and the area was about 1/4 of a square meter. I'd originally bought these panels to go on my boat, and that's what they were designed for. And you're supposed to glue them directed to the fiberglass hull of a boat. That was the idea behind them. But I actually mounted them on a board just using screws. They're supposed to be flexible, but I think if you flex them too often, they fail. And when I was in Australia visiting relatives and friends, I managed to buy some devices from Dick Smith. It was an Australian electronics company similar to Radio Shack. Unfortunately, they no longer exist. But I bought these kits for voltage doubling regulators, which were quite a simple circuit. Basically, it was a 555 oscillator and a couple of rectified diodes and a bypass diode. So if the voltage was bigger than the battery voltage, it bypassed this doubler. If the voltage fell, the doubler would supply some current, but at a very much reduced rate. But I used to use this on my boat, and it would keep my boat battery charged forever and a day with just a very small trickle charging when it was cloudy. Right. The other panel, panel 2 out of the 3. This was 10-watt amorphous silicon panels. I bought these at a rally from Key Solar Systems, Wales. Basically, they're pieces of glass that look brown. That's the colour of amorphous silicon. Crystalline silicon tends to look bluish or black. They were okay. I had 5 of those to give me an open circuit voltage of 20 volts. And that also had an area of 0.23 square meters. And that had a voltage doubling regulator on it as well. Panel 3. This was a commercial made-up panel in an aluminium frame made by BP Solar, who have since pulled out of solar power. I don't know why. Well, they pulled out some years ago, but this was a much more efficient panel. It was bigger to start off with. It was a 40-watt panel of 1/2 square meter. These crystalline silicon panels it's pretty much what you'll get now if you buy a solar panel. They're much more efficient than the amorphous silicon ones. And again, 20 volts open circuit. It was unregulated, but it had the option to feed the dump regulator that was in the wind generator control box. Right, they were all mounted on adjustable frames and manually steered to point towards the sun. and that's what they look like. The BP panel's the one on the left, the one in the middle is the amorphous silicon. The aluminium box is the voltage doubler. The voltage doubler on this one is there, and these are the flexible panels. They've since all failed. They were just over two volts a panel, so they were all wired in series. And I did actually have them fitted to my boat at one time, but so they've since all failed. Never did figure out what the failure mode was, but anyway, the overall performance. The generator ran almost continuously for 30 hours. The following year, I dated it in 3 hours because we ran pretty much the same sort of station again the following year, and there was practically no wind that year, so we had to rely on solar. The batteries were left to charge while the station was dismantled after the contest. The batteries were charged up before we went, obviously, but they were actually charged using this system. So all the power we had was derived from wind or solar power. There was no mains charging ever used on these batteries. The average power output was estimated from spot measurements to be about 35 watts, which was equivalent to approximately 100 amp hours of energy at 12 volts nominal. Several peaks of over 60 watts were recorded, and many more noted from visual and oral estimates of the turbine speed. Yeah, when there was a big gust of wind, you could hear the turbine speed up. It didn't get particularly noisy. It didn't really detract from operating anyway. And so about 30 amp hours was provided by the solar panels. It was necessary to use a spare battery and bank 5 for the 2 meter station for 4.5 hours. That was because the terminal voltage dropped, so we switched in another battery that was kept for that purpose. Weather conditions, it was pretty mixed, with only short spells of sustained sunshine, but we had relatively high winds, which kept the wind turbine turning. I don't think it actually stopped from when we first put it up to when we took it down. It was, even though some of the time it wasn't actually generating anything, but it was still turning, which was quite reassuring. Incidentally, this site, Burton Dasset, on another part of the site away from us, there is an old windmill, or what's left of it. Excuse me. All that's left of it is a stone tower. So it is. It's known as a windy site, but as I said, the following year there was practically no wind at all. All right, the batteries. We had 12 lead acid batteries, and they were all charged from the solar panels and the wind turbine before we left home. And they were divided into 5 banks. And these were the various type of batteries that we had. And this also includes the batteries it says dry cells here. I think they're lithium cells, to be honest with you. Don't know what was used in laptops in those days. It was 20 years ago. Oops. And that's what the batteries look like. These 1, 2, 3, 4, 5, I think there are. Is that right? 1, 2, 3. Those are UPS batteries. They were very heavy. I bought them from a guy in Southampton at a rally. I'll tell you where I bought them. I bought them at Didcot Rally in Oxford, and he'd come up from Southampton, and I bought some more the following year. And when they weren't operating the contest station, they were at home operating the lights in my house. So those were UPS batteries, the deep discharge ones, and this is an ordinary car battery. These aren't ideal for running radio stations. They're designed to deliver a lot of current for starting the engine, and they don't like being deep discharged. But I can't remember why I got that particular battery. Anyway, that's the control system. This gizmo here is the dump load. There's 4 twin filament light bulbs in there to put a load on the generator should it start turning faster than we wanted it to. These devices here are actually voltmeters. They're LED bar graph voltmeter kits that I probably got those from Dick Smith as well. That one's showing amber. This one looks as though it's showing amber and green, which is a bit odd. This box here, it actually says UHF transmitter on it. Ignore that. It was a box I cannibalised from some commercial kit that did once upon a time have a UHF transmitter in it, but that contains a 3-phase bridge rectifier. And the switch to the over voltage switch to bring in the dump load, and it is mounted on a piece of plywood with 2 stainless steel hooks, which conveniently hung on the frame of the tent. Right, logging was done on paper on pre-printed log sheets, and we used pencils for logging. We found they're much better than biros, and the contacts were logged onto a laptop from time to time when we got a spare few minutes. That was the software that we used. It ran on DOS in those days. Signal reports for the for 6 meters, 2 meters and 77s, the contest exchange is your standard RS and T. If you're using CW, you can use any mode you like, but nearly everybody used phone, sideband phone, and you gave your locator. But on 70 megs, it was different because the contest was split into 2 parts. So you sent, I think the first session was CW, so you sent RST plus the locator plus the distance from the nearest city or town, and then that lasted for 8 hours. It was 8 hours off, and the final 8 hours was the phone part of the contest. I might have got that the wrong way around, but anyway, it was 8 hours CW and 8 hours phone, and you sent the RST locator, but the distance was from another city or town. The last bit of the information had to be different from what you sent in CW. It's to I think it was a device to stop cheating. And our information, the locator was Italy Oscar 92 Hotel Echo, and it's 5 kilometres east of Gaydon, which some of you may have heard of. It used to be a V bomber base, but it's now a test track for automobiles. And that's Bob G4GE with some lubrication to keep him going. He was our only CW operator on this occasion. He looks as though he was enjoying himself. Accommodation and sustenance. We had tents to sleep in overnight, and we had camping gas stoves to make tea and coffee. We had a polypin of Hook Norton, and the main participants were Brian, who's now Silent Key, Dave, who provided a lot of the equipment, Bob, who did a lot of the operating, Brian, who did some of the operating. I don't think Brian stayed overnight. I'm not sure about that, but and myself, who provided a lot of the kit and did a fair amount of operating. Right, so the conclusions. This exercise to operate a field house station with sustainable energy was shown to be possible. The relatively simple electronic controls were employed to control various banks of batteries. There wasn't much in the way of voltage regulation. We relied on the fact that the batteries were being float charged, so the batteries acted as the voltage regulators in effect. Thoughts for the future. I mean, this was what I've just described was what we did 20 years ago. And we think perhaps there ought to be another section in VHF NFD for groups using sustainable energy or a variety of renewable energy sources. We also showed that in the case of the need for an emergency communication, sustainable energy sources are a viable proposition. And the station could have operated for another 24 hours at QRP levels, 10 watts. The RSGB's definition of QRP was 25 watts. I'm using the GQRP Club definition, which is 10 watts phone and 5 watts CW. And it could operate practically indefinitely at reduced duty cycle. If, say, you were using hourly skeds. The sort of thing that would happen in a real emergency is you'd be required to relay various bits of information, well, depending on the nature of the emergency, what sort of equipment needed to go where, you know, things like medical aid, food and so on. And I would think that the best way of exchanging this sort of information would be using one of the digital nodes like PSK31 or RTTY. And you can exchange a lot more information like that. Of course, if you get desperate, you can use Morse code, but PSK31 is more efficient at sending large amounts of information. So if you needed to say send a list of 50 names, then you could do that much easily using a macro in PSK31 than somebody sending it by CW, either hand sent or using a keyboard. Anyway, you know, I reckon we could keep a PSK31 station going for days on end. The biggest problem would be the operator fatigue and running out of food. So you could use, as I said just now, you could use macros to store and resend info. And you could do that with using an FT817 or 818 and an iPad. Right, the other thing I would do if I was doing it today or later on this year, I would switch to lithium batteries because they're a lot higher and they've got a higher terminal voltage. So most of these rigs will work best with a 13.8 volt. In fact, the IC736 would barely work with a fully charged lead acid battery. It didn't like low voltage on 23 SEMS at all, and anything below about 12.5 volts and it went a bit doolally. So it would work much better off lithium batteries, and they're obviously a lot lighter than lead acid batteries, and they're just as capable, if not more so, providing the power needed. Right, voltage regulation. I do things differently these days. So we didn't really have any voltage regulation. It relied on the batteries being float charged. But now you can get DC in, DC out regulators and set the voltage to with a pop. And you've also got things called charge controllers, which are designed to connect to photovoltaic panels, and they will also cope with the wind turbine output, which is what I've done at home because I run my lights in the house off solar power. And this is one of the regulators. These are pretty cheap. Oops. I'll get this right in a minute. Right, that's what's known as a buck regulator. The terminal block on the left is power in and power out. At the moment, it's only got power in, I think. The blue pot on the right-hand edge next to the toroid is how you set the voltage. So you can use this to deliver, say, 13.8 volts by setting the voltage with that pot, and you can discharge the batteries down to the minimum that you want. If it was a lead acid battery, you wouldn't want to go below 11.6 volts. And if you do go that low, you want to be able to recharge it pretty well straight away, otherwise the plates sulfate up. Not sure what happens with lithium batteries if you leave them in the discharge state for very long. But again, this would regulate the output from a lithium battery just as well. Charge regulator. This is one I bought recently, and these are quite cheap. That one cost me £6, and it'll handle up to 10 amps. It's fused. There's that blue thing in the middle is a fuse. It's got two useful USB outputs, so you could use this for charging mobile phones or tablets. Computer tablets, that is, or iPads, that sort of thing. And basically the PV panel goes in on these terminals and the load is on these terminals. I think that's meant to represent a light bulb, but that's the load side. That's the PV side, and these two terminals are the battery, where the battery goes. So that will regulate what's going into the battery and what's going to, it'll shut down if the terminal voltage on the battery goes too low. This is another one. this is designed for use with lead acid batteries, and I think I only paid about a fiver for this, and I bought several of them, and I've two have actually failed. I'm not quite sure why. Probably, I think something became disconnected, and you have to be careful with these things. You have to connect the battery up first before you connect anything else, if I remember rightly. And I suspect that a connection failed. It lost its battery. Anyway, I didn't like it, but I'm sure I only paid about a fiver for these. But when I looked up on the internet a week or two ago, they were asking 25 quid for one of these. So I decided I'm going to be a bit careful. Right, going back to the antennas, the other benefits of having omnis is that the lower VHF band, 6 meters and 4 meters, the double turnstiles have got as much gain as the sort of beam that most amateurs could put up, which would be on those bands about 5 or 6 element Yagi. I mean, that's doesn't sound much, but the size of the elements of the antennas, that's a big antenna. I used to have a 3 element Yagi for 6 meters, and that was on a boom that was 10 foot long. So if you went to 6 elements, that's a 20-foot boom. That's a big antenna. These double turnstiles are a lot lighter than that, and much easier to put up. The main lobe of the double turnstiles tilted upwards by about 6 degrees. That figure depends on what height it's at. So it aims at a point just above the horizon, which enables over the horizon refraction in tropo openings, and it's also good at hitting distant ES clouds beyond the horizon. Our best DX on 6 meters, I think, was Cyprus. That was an ES only. And that slight tilt also reduces ground noise pickup on receive. But as I said before, the drawback is because they're omnidirectional, you can't null out any noise that's coming in. And as I mentioned before, on transmit, there's the advantage that everyone within range can hear you all the time. So it keeps the frequency clear. That's only really true if you're running a fair amount of power. But having said that, even with a modest amount of 10 or 20 watts, the ERP is quite high. And of course, we had available on this occasion, we had 100 watts available on 6 meters, a lot less on 4 meters where we were transverting. I think we only had, no, it was 8 watts on that rig, wasn't it? Previous years we'd had a transverter with them, but that only put out about 10 watts. Right, at UHF and above, the turnstile antennas and phase isolators get more complicated, and they start to get lossy as well. And you have to double everything just to get another 3 dB again. But then that's true of Yagis too. And 3 dB is only half an S point. But the advantage of antenna gain, of course, is that you get that gain on receive as well as on transmit. 23 sems and upwards, you get more gain using the dish and the conical reflector as an omni fly swatter. That setup that I showed you before, the omni fly swatter had a gain of around about 20 dB. Right. that is it.
Brilliant, lovely. Thank you, John. As you were talking and going through your presentation there, John, I can see in front of me the members of the club here who would immediately have questions and comments to make about the work you put into building that sustainable station. So I'm going to throw the microphone open. Who wants to go first with a question or comment to John? Jeff.
Good evening. Good evening, John. Thank you very much for this interesting presentation. Very interesting about these antennas and also about the concept of sustainable field day. It would be a good idea to have a section and the rules and the field day rules for such a setup. I think that's a very good idea. But nevertheless, on 2 meters and 70 centimeters, I'm just asking, with these turnstile antennas, what is possible? What kind of contacts could you make? Could you make it into Europe, for example, or how good is that working? On the other hand, the advantage, I think, of such an omnidirectional thing is that you don't miss openings. You could beam to the east and there could be an opening to the west, for example. So you will not miss that. But on the other hand, I'm just wondering how good that works on 2 meters and 70 centimeters.
Well, they work very well on 2 meters. I have worked northern France with 1 watt of SSB.
Okay.
To a double turnstile on, that's on 2 meters. 70 SEMS from that contest site, which is nearly 700 feet above sea level. We've worked the south coast from there, which is getting on for 300 kilometers. And we've probably worked Scotland as well, which is probably a bit further away. And we've worked into Holland and probably Belgium as well. On the lower bands, 6 meters and 4 meters. 4 meters, we've worked Gibraltar, because there weren't so many stations around that had 4 meters in those days. But from home, I've actually worked Iceland with 10 watts on 4 meters with a double turnstile. And 6 meters, well, if you get ES openings or F layer propagation. I mean, the furthest we got in the contest was Cyprus on 6 meters, but I've worked Guinea-Bissau in Africa from home with 1. And I've also worked a station in Rhode Island on 6 meters, but could have probably worked those stations with a dipole anyway.
Yeah, yeah. If there is sporadic, especially. Thank you,
yeah,
John.
So DX is possible with these antennas. And of course, you don't miss out, like you said, you don't miss openings.
Yeah, true.
With it being omnidirectional.
Great, thank you, John.
Okay, thank you, Jeff. Who wants to go next? Got a question or comment? Yes, Gerald.
Yeah, just a quick one. Thank you very much for that there, John. It was really interesting, especially your description of the site near Coventry, because first job after I left college was at Stratford-on-Avon. So some of the members of the Stratford Club worked in Coventry area as well. So we got to know that quite well. However, just onto this, the simple question, first of all, the solar charge regulator for the lead acid battery, I didn't see a maker's name or a site. Was it just on eBay or something? And any other comments you'd like to make on those? I've got lead acid batteries here at the moment, but I'm worried about the charger for the lithium batteries. You need to be able to monitor temperature as well, don't you? Over to you.
Right. No, I can't see a maker's name on it either, and I've had it out of its box. Made in China, as you might guess. And came either from eBay or Amazon. I can't remember which. It was a few years ago since I bought them. Comes with a little leaflet that tells you how to wire it up and that, but no maker's name on. Well.
Probably is China then, I guess. I wondered if that might be the case. And what about the charging of the lithium batteries you're thinking about? I haven't used lithium yet, and I understand you have to monitor the temperature while you're charging them.
Oh, well, I haven't actually used that one yet. Bob G4GE put me onto these, and he's using one to charge a 20 ampere lithium battery. This one is made by Sunix, and it's got a an LED display which has got a lot of information. It's actually got a thermometer symbol in the top left-hand corner. So I think it does monitor air temperature, but it's not really monitoring battery temperature. But the lithium battery that I've got, which I'm not sure where it is at the moment. Well, I don't know whether you can see that. This camera is not very good. It's pretty low resolution, but that's actually a motorcycle battery. It's a 5 ampere battery, and it will start a motorcycle engine up to 150 cc's. The maximum discharge current is 90 amps, would you believe? So I've bought that solar charger to regulate that. But that has got its own built-in regulation, in fact, because you can just connect this to a motorcycle alternator and charge it. And in fact, normally I charge it off a bench power supply. But I thought I'd get one of these solar regulators and see if it does the job properly. But it's got these other useful features like the USB output for charging phones and the like. So I can't tell you much more about that. Sorry.
No, it's okay. That's fine. It's point me in some directions I want to investigate. Thanks a lot, John. Over to you.
Thank you, Gerald. I've got Roger next.
Hi, John. Thanks for that. Very interesting. I did look up, by the way, your BSV28. They're £9 on eBay or £3 from China still, so they are pretty cheap if you want to. The question really was regarding the light bulbs. I wondered how big the load was that you needed to put on for that little alternator, and did you do any comparison for costs in respect of how much you would have had to pay if you were paying for the electric off mains or buying fuel for the generator? You know, what was it? How much fuel? How much did you use, into the words, in terms of cost of electricity? I wonder if you did that cost comparison.
Well, it's a long time since I've done a costing exercise. I've got two solar systems at home. One's my own installation, which I just use for charging batteries and operate the lights off. But I also have a commercial system which has got a grid tie in it, so I actually export energy to the grid. But I try and use as much as I can because they're charging me something like 16 pence per kilowatt hour, but they're only paying me 4 pence a kilowatt hour for what I export. So I try and we change the way we do things. Instead of running the dishwasher and washing machines overnight on economy 7, I run them during the daytime when the sun's shining. So I've not really done that costing exercise, because you've got to do a lot of conversion figures to to translate it back into kilowatt hours to price it. And I can't remember what the figures are offhand in my head. I can't work it out in my head this time of night. Sorry.
That's okay. I was fascinated by the wind turbine though. That's a nice little bit of kit. That's tremendous.
Yeah.
Rewinding your own motor there, your own generator. That's going some, is that? Thank you.
Yeah.
Okay, thank you, Roger. Who's next with a question or comment to John? Unmute if you don't see me get my attention.
Hi there, it's Brian.
Yes, go ahead, Brian.
Yeah, great talk. Thank you very much, John. Enjoyed it and very interesting. And having done a lot of Salter and actually done an expedition to Peel Island, just off Morecambe there, and what have you, with batteries. That must have been one hell of a feat 20 years ago with that much weight, etc., going up there. So hats off to you to that. And obviously, yes, definitely lithium now. I have a little lithium 10 amp an hour battery here that I've just bought, and that is super duper. But very interesting with the turnstiles, and yeah, really enjoyed it. And thank you very much for the talk. It's more a comment really than a question.
Okay, fine, thank you.
Yeah, thanks, Brian. Ian had a question to you, John, and that was about whether the charge controllers produce any noise that affect radio reception when you're using them.
I haven't really noticed any, because I did have that lead acid one is in the garage next door to me is where I keep the batteries. What I'm actually using now is, because those lead acid batteries have got a lifespan of about 10 years. So I weighed those UPS batteries in for scrap some time ago. And what I'm actually using now is tube train traction batteries. And I've got 6 of those at 200 amp hours a piece, but they're 6 volts only. So that works out at 600 amp hours at 12 volt nominal. And that goes through an inverter, and even the inverter doesn't, it's not a particularly good one. It's not a sine wave. It's one of these synthetic things with a step waveform. And even that doesn't produce very much noise. I do have problems with noise, but it's not coming from my house. There's something local to me, which is started up in the last couple of months on 6 meters, and 80 meters I've got S9 noise all the time. 40 meters it comes and goes, but it's nothing that I'm doing. So I don't think these charge controllers produce a massive amount of noise. I expect if you put a sniffer up next to them, you'd find some, but generally speaking, they're pretty quiet.
Okay, thanks for your question, Ian, and the answer there from John. Anyone else with a question to comment to John? John, yeah, go on, Richard.
No wonder I missed my train this morning. I was rushing on the tube and it wouldn't start. Can you explain? No, the fly swat reflector that you use, what's it made of?
Chicken wire.
Is it? Okay.
For 23 SEMs, I just use chicken wire.
Right,
if you
okay.
Use 10 gigs, I'd probably use a solid aluminium sheet.
Yeah, my next question was, how on earth did you keep it to spec? Because if you take a fiberglass dish, it's quite strong mechanically. But if you use one of those reflectors to assemble it, did you, with the chicken wire one, did you use sections, triangular sections?
What I did was I bent some 15mm copper tube, used T-pieces and 6 radial arms as to make a stiff ring, and then the apex of the cone I tied it with some polypropylene cord to the feed point of the antenna so that it was lined up. But basically it was just dangling there. I've only ever tried it out a couple of times. I'm in the process of rebuilding it in the more compact form so that I can just put it on the car roof and just drive somewhere and use it. Because I say it was a bit unwieldy with this scaffold. Well, it was like an hangman scaffold made out of scaffold clamps and bits of aluminium tube, and that was sort of lashed to the roof rack and the door handles of the car I had at the time. So it was a bit Heath Robinson, but it worked anyway.
Yeah, you know, the other thing is with these lithium batteries, I'm just wondering if you put a current constant current regulator on the end of one of these chargers, exactly the same as yours, except it's got no fuse in it.
Oh.
But I haven't tried this one. I've got other ones which I use to keep my caravan battery charged over winter. A solar panel. I think I've had one nearly 20 odd years on that method, and it's still as good as new. But it says full protect, whatever that means, built-in timer, and you can set your own voltage on it for your charging voltage. So I've just wondered this combination, whether it would be suitable for lithium batteries.
Might be, I don't know. Lithium batteries aren't as fussy as people think they are in their charging requirements. They're very similar to lead acid from that point of view. You can use a constant. You don't need a constant current charger. You can use a constant voltage charger for lithium battery. Yeah,
because with nickel metal hydride, you can use. It's best to use a constant current over a certain period.
Yeah, they're similar to NiCads, aren't they?
Yeah. Well, yeah. I just, you know, the other thing when you mentioned you can't use a car battery because it's designed for high discharge currents, which it is. But when you use, say you're using mobiles, I mean, I've had a battery failed in me Avenger years ago. I shouldn't say this, but I had 160 100 watts, 160 main 100 watt rally lights in my Avenger, and I had to get a 65 ACR, and they were brighter than these LED modern cars LEDs. You couldn't look into them in July, August time at midday with full sun, and each bulb drew 16 amps. And like I said, I had to get a 65 ACR. That was the biggest alternator in the 80s that I could get to power these things, and it was straight off the battery with a relay. But it failed on me, and I went in, and the chap at the garage said, "What are these aerials for?" And I says, "Well, they're for amateur radio, because I'm running a FT 707 mobile in them days, because you could fit it on your just in front of your saddle, in front of your gearbox." And he says, "Oh, these batteries are designed for transceivers. They're not for taxis, because they had special batteries for taxis, you see." So I said, "Why? What's wrong?" I've measured the voltage. It don't go up and down. It's 13.8 on full charge. And they said, "Give them a new battery." But I was just thinking from what you said earlier, if you had a big capacitor, say an electrolytic on the battery, whether you could use a car battery with a capacitor as an additional reservoir.
I don't think there's much point. The problem with car batteries is they're designed to deliver large amounts of currents for short duration or small amounts of currents for longer periods. What they don't like is being deep discharged. They don't like being discharged for long periods of time without being recharged. once you've started your car, your electrics are running off the alternator anyway.
That's right, yeah.
And you're just keeping the battery topped up, ready for the next time you want to start it.
Yeah, yeah.
The problem with is if you use it to power a radio station outside of a vehicle, you'll discharge it down to 11.6 volts. And if it's not being recharged, what happens is the plates sulfate up and
Yeah.
the battery loses its capacity.
Yeah.
As the deep discharge batteries, the UPS batteries, or these traction batteries, you can draw current out of them for much longer periods. Still got to recharge them, because if you leave it discharged for any length of time, the plates will still sulfate up. Yeah,
I know. I've had problems with a battery on my car, because I've got one of these DVRs, and I plug it in, instead of wiring it into the ignition system, I have it plugged in into the cigarette lighter, and I leave it overnight. And if I forget, I do that a couple of times, and then the car won't start.
I'll tell you something funny about cars and batteries. I used to have a 100 amp hour leisure battery, which I had in the boot of the car, and I used to run my radio gear off that. And it was a Merc, actually, a C-class Merc, and it had one of these cigarette light sockets in the back. And what I used to do was plug a lead into that and charge this leisure battery up as I was driving along. Did that one day, put all the radio gear away, and I left this thing connected in, and the engine was switched off. Come to start the car, and it wouldn't do anything at all. And I thought, what the hell's going on here? And in the end, after eliminating everything else, I thought, well, the only thing that's different is this battery in the boot. So I disconnected it, and then the car would start. Really odd, that. It was powering up back through the socket. It was powering something up in the car which wouldn't allow it to start.
All right. Really, that's a good anti-theft device.
Yeah, I mean, it'd fool pretty much any car mechanic, I'm sure.
Thanks for that, Richard. Right, anyone else with a question or comment to John? If not, can we first of all show John the normal appreciation at Denby for a good contribution? So thank you, John.
Thank you very much.
No, that was a very interesting talk, John. Really enjoyed it. I guess the question no one's asked you yet, and I'm going to ask it before you go. How did you do in the VHF field day that year?
About the same as we did in previous years, somewhere in the middle. We never looked like winning it. But we weren't bottom, certainly. And our DX was probably almost as good as anyone else's. So the thing about VHF propagation is that the signal goes as far as it can, goes to the limit of propagation. The only difference with running and more power is that it's louder when it gets to the limit of propagation. With the bands being so quiet as well, you can work enormous distances on very low power. Proves time and time again.
Okay, well, thank you very much, John. And various people did make some comments. I think in the chat, a couple of people commented. There was a Terry from the States, W3WPS, and he just said, "Oh, I've got lots of ideas for me to follow through from that talk." So he wanted me to pass on his thanks to you, John. So on that note, I'm going to turn the recording off and thank John for his contribution tonight. It was extremely interesting.
Can I have a beer now?